Have you heard of temporal interference, TI, electrical stimulation? A revolutionary concept of non-invasive deep brain stimulation, DBS. Curious about what it takes to develop cutting-edge neuromodulation techniques while pursuing a scientific career across two continents. Welcome to the Women in Neurotech series of the Neurocareers Doing the Impossible podcast. In this series, we shine a spotlight on extraordinary women transforming the world of neurotechnology, paving paths for future generations, and breaking barriers, one groundbreaking idea at a time. Meet our guest, Acerbo, PhD, a trailblazing neuroscientist currently working as a postdoctoral fellow at Emory University in the United States. Emma's work focuses on non-invasive deep brain stimulation using temporal interference, a promising innovation for patients with epilepsy and beyond. TI uses overlapping electrical fields to target deep brain regions with precision, all without invasive surgery. It's fascinating to consider the challenges and opportunities that come with pioneering such innovative methods. But Emma's journey doesn't just stop at the lab bench. Originally from France, she made the bold leap to pursue her PhD and postdoctoral research in the United States. Her unique transcontinental experience gives her rare insight into the differences between European and American approaches to science and work, an invaluable perspective for anyone considering a similar academic or professional transition. Emma will share practical career advice, especially for women looking to make their mark in neurotechnology. From finding the right place to do research to managing clinical projects and making the leap into neurology research, her story is packed with lessons and inspiration. I had the pleasure of meeting Emma at the Neuromodulation 2024 conference in New York City, and her passion for advancing medical research and improving patient outcomes left a lasting impression on me. Her dedication to pushing the boundaries of neuromodulation is nothing short of inspiring. So, are you ready to explore a career in neurotech? Learn about cutting-edge non-invasive brain stimulation techniques? Or get tips on navigating a transcontinental research career? Then this is an episode you want to listen to. Join us as we dive into Emma's journey and uncover the future of brain stimulation technology on Neurocareers Doing the Impossible. Dear Neurocareers podcast listeners, today we are starting our new series about women in neurotechnologies. And our guest is Dr. Emma Acerbo, and Emma will be talking about her work in neuromodulation. So, first of all, Emma, welcome to our podcast series. It's a great pleasure to have you today on our podcast. And can you tell our listeners, please, where you are joining us from what part of the world?
So, hi, it's a very pleasure to be here with you today. I am right now in Atlanta, USA, in Georgia. I'm working at Emory University, but as you can hear, I have an accent. I'm from France. So I did my PhD in Marseille also in neuroscience.
Wonderful. And can you please provide your brief background? You already mentioned several things, but how did you get to this field of neuroscience, neurotechnologies, and finally neuromodulation? What was your path to this field?
So I started my PhD and I had two PhD advisors. One was an electrical engineer, Dr. Williamson, and the other one was a neurosurgeon in Marseille, so Dr. Caron. I did my PhD and I was the link between them. We started to work on this neuromodulation technique called temporal interference, which bring together the technology and also the neuroscience. And yeah, that's how I started. And so neuromodulation with TI is just deep brain stimulation in a non-invasive way.
Thank you so much. And I would like to go a little deeper in history. When you were growing up, what was your career aspiration? What did you want to become? I know that all adults are usually asking little children, yes, who do you want to be when you grow up? So, what was your answer?
So when I was a child, I wanted to be a dancer, but I was very bad at it. So I had to, change the path. And I was really into science, mathematics, physics, and biology were my main interests. And then when I decided to go in study, I was very into psychology, neuroscience, and I wanted to work on the psychology of criminality. But I was thinking that maybe science I could bring with neuroscience, I could bring both the biology and math that I liked and also the how the brain is working and combine them together. And then I decided to pursue my career in neuroscience.
What was the biggest highlight for you when you were getting in touch with the field of neuroscience? What was maybe that inspirational moment that really inspired you to go further and explore neuroscience and neurotechnologies?
So my biggest inspiration was a woman. She was a neurologist in Marseille, Dr. Trébuchon. And she was so kind and she was so intelligent, so smart. She was really the woman that I wanted to become. That's when I decided, like, I want to be like her. I want to, when she is talking in a group, everyone is listening to her. So she was a big inspiration for my career and she helped me to find my two PhD advisors. So she was like a big help for my career. So if I have to say it's that my inspiration was that in Marseille.
Thank you. And how did you approach her? I am asking because some people, they see some figures that are inspiring them, but they're hesitant to approach, hesitant to ask for advice, hesitant to ask for help. How did you work through that? Did you also have those hesitations and how did you overcome them?
So yeah, I was very shy, but I worked with my mom. She's an hairdresser and she was putting me in those big conference of hairdresser and she was giving me calls and she said, go talk to the people. And I had the chance to be pushed and always like go beyond. And she told me once something that I will never forget is that people are more afraid of you than you are afraid of them. So with that in mind, every time that I'm going to speak, to talk to someone, I'm always thinking of my mom saying, they're more afraid of you than you are of them. So yeah, but I mean, I am shy. And so I understand that it can be very complicated, but it's always important to push your boundaries and reach people. They are nicer than you're thinking. Yeah.
Yes, thank you for noting that. And I think that's also a very important point for our listeners, yes, who are at times might be shy. And actually, many of us, I'm also a very shy person. However, like you said, it's very important to push those boundaries and try, nothing changes even if you receive no, yes. But at least you have an opportunity for yes. So growing up and pursuing a career in science, in technologies, having this angle of studies, how did you feel in your surroundings? Did you see many girls growing up and pursuing similar career, or maybe it was kind of unique for you as a woman to pursue that career in science and math? Yeah.
Yeah. So I did my PhD with two other PhD students that were men. Both of my PhD supervisors were men. I'm not going to say it was difficult. I never felt something like that, but I was very glad to be surrounded by other women, other PhD students. And I think being part of a sorority, we were in a lab doing, science together. And having this sorority, I think really helped me. It's important to have, I was in need of being a part of the sorority, and I was really glad to find it. I understand that now some women can feel a little bit isolated. If I didn't have interaction outside of my own lab, I would have been very sad. So that's why I think it's important when you are pursuing a career, when you're starting your career in neuroscience and specifically in neurotechnology, it's important to bring the sorority together and be a part of a girl team. Yeah, I think it's really important. I'm not sure if I answer perfectly the.
Yes, absolutely, absolutely. And now let's talk a little bit about the event where we met. We met at the Neuromodulation Conference in New York, like I already mentioned. So, can you tell our listeners what were you doing there, in addition to, of course, learning about the latest trends in neuromodulation?
Yeah, so I had the chance to have a poster highlight and present my work at the New York Neuromodulation conferences. The thing is, the problem when you start working and be really isolated on your topic is that you don't know what the others are doing if it's outside of your subject area. So I think it's really important to know, even if I'm working on a non-invasive electrical stimulation technique, what are doing the TMS people, the transcranial magnetic stimulation, what are doing focus ultrasound. And even if it's not the same technique, it can give you insight of how you can perform better protocol, how you can test, and how does your technique is placed among all of the other, and what are strengths and the weakness of all the techniques. So yes, I was presenting, but I was also learning a lot really about the other techniques.
And the topic of neuromodulation becomes more and more popular, I think, with every day, really. Why do we think is this trend to developing more neuromodulation techniques, improving them, finding their various applications? What is the reason behind that?
So I'm thinking that the brain is a black box and we are trying to understand it because we are also looking a little bit to understand ourselves. So that's why I think everyone is really that's why I am to say it, because I want to understand how my brain works. Which I think is great with neuromodulation is that researchers are understanding that by modulating the brain, yes, you can have a therapeutic effect, but you can also have more, you can understand the cognitive function. There are a lot of insights you can get from the neuromodulation, and that's why it's touching so many fields, cognitive neuroscience researcher, medical doctors. So that's why I think it's very, you can learn more. And plus you can work when it's non-invasive, and in some cases invasive, but in patients, you can also learn more on humans, the human brain. I'm doing a lot of clinical work, and I think rodents' brain and rodent research is great, it's very interesting, but sometimes we have this issue of translation from the rodents to the humans. So I think the neuromodulation, especially the non-invasive technique, allow researchers to understand more about the human brain. And that's why I think it's very.
How would you define the field of neuromodulation? What is neuromodulation? Maybe for those who are just first time hearing this term.
Neuromodulation is a technique that will disturb a little bit the brain. It can be subthreshold, so it can just modify some state, some oscillation of the brain, and it can be subthreshold. So, for example, you can evoke a movement, you can like have a real output of the brain. So it's just to activate pathways and networks that will lead to an action.
Thank you very much. And maybe you can provide us just a very brief perspective of how this field started. What were the basics of developing this field further?
So if I remember correctly, the very first electrical stimulation neuromodulation were, I think it was the ancient Greeks that were placing torpedo fish on the skull to cure migraine and I think also some pain relief. So I think that's the first, for the brain, the first neuromodulation, I would say. And then you have some electrical stimulation when people were accessing the brain and they were stimulating. So that's where it started. But right now we are more doing neuromodulation for treating diseases such as epilepsy. You can do also one of the main milestone of neuromodulation, I think, because it's a mix of Emory University and France. It's for Parkinson, the GBS stimulation. That's a huge milestone, I think, in the history of brain stimulation. So when you insert the electrode in the brain, you can stop the movement of the Parkinsonian patient, and then it move on from there. It move on from to go to epilepsy, to go to depression, OCD, this kind of disease that people are trying to treat with stimulation right now.
And what is the major change that you see in the field of neuromodulation at the moment, maybe when compared to 10 years ago, to previous years? What are the newest trends that you can see in the field?
Right now, I think the main challenge is to be non-invasive and having enough strength to do sub-threshold sub-threshold effect. So I think that's where a lot of effort are putting into. So right now, in terms of transcranial non-invasive stimulation, you have temporal interference, which I'm working on. You have the transcranial focus ultrasound, which can both go deep and stimulate at depth without the need of something implanting in the brain. Yeah, I think that's the two main paths that people are working on right now.
Thank you for mentioning that. And maybe you can talk a little bit for our listeners about the previous constraints of stimulate deep structures of the brain without doing the invasive stimulation. Why this was the case and what prevented people to stimulate deep non-invasively.
So when you have the normal stimulation, if I may start like that, so a direct current stimulation when you have, and you have the alternating when you have a waveform. So the people are started to use these two techniques, transcranial alternative and or current direct current stimulation. They started to apply it on the brain and try to stimulate, but it didn't do a lot of stuff. And we saw very quickly that it was affecting only the cortex of the brain. So there's no possibility to reach deeper structures such as the hippocampus, the thalamus, unless you implant in the probe inside. So that was the constraint. And then what's the rest of the question?
Yes, so now the next question, how you are solving this problem with your technique, yes, temporal interference, how do you approach this problem and what solution do you propose?
The solution, in fact, is very simple. You just, instead of when you're using a transcranial alternating current stimulation, you're using frequency of stimulation of 20 hertz, 10 hertz, or whatever is recommended on different pathologies. The idea of temporal interference is just on the principle that high frequency will penetrate the tissue more, and the idea of higher frequency above 1 kilohertz is not affecting the neurons. That was the two first idea from temporal interference. And then if you had the idea of adding another waveform, we create an amplitude modulation that you can tune, you can use. For example, if you want to do a 20 hertz stimulation, you can use, for example, 1000 hertz and 1020 hertz. And when you mix them together, you will see an amplitude modulation of 20 hertz. And the main idea, the main concept was, does this amplitude modulation at 20 hertz will have the same effect as a stimulation at 20 hertz? So that's what we tested. First, the team of Grossman showed that it was activating neurons. And then I personally tried to apply that in the context of epilepsy, because epilepsy can be, so the seizure can be reduced if you have a stimulation in the hippocampus or in the thalamus. And so my question was, does the TI stimulation can have the same effect as inserting an electrode in the brain in order to cure or to reduce at least the seizure in epilepsy patients?
Yes, very good. Very good. Thank you. Thank you so much. And can you tell maybe more about your studies? What was the main goal? You already described in general. So, what was the goal and what were the results that you've achieved so far?
Yeah, so I started with mice. So the first paper of Grossman was done, and collaborator was done mice. And there was there is a very famous figure from them where you have the dentate gyrus. So it's a very substructure of the hippocampus that was activated by TI. And the hippocampus is a target for epilepsy. So I decided to take the mice, having them having seizure. And then my question was, can I reduce not really the seizure, but more the biomarker of epilepsy with TI? So that's what I did. And we saw that we could reduce all the biomarker of epilepsy with the TI. So for us, it was a win, because we were like, okay, so TI has an effect on the brain, and TI has an effect on that specific pathology that is epilepsy. But the next question was, can we really, it was really the beginning of TI. It was right before 2020. And we were wondering if that technique could translate to human. Can we really apply TI and target the structure? And it was a work in collaboration with also Dr. Grossman, but also Dr. Violante, that was in the conference. And we were implanting electrodes in human cadavers in the head. And we just stimulate with TI, and we were able to record this amplitude modulation in the target. So for us, it was, again, the hippocampus of the human. Then we were like, oh, that's great. We can have this amplitude modulation. If the amplitude modulation is really working as we are thinking it is, we can definitely record it where we want. Then I continue to work on epileptic patients. And so we performed the TI stimulation, and we came back a little bit to our previous study on, does TI has an effect on the epileptic biomarker and in human? And yes, it does. We have also this decrease of enterictal epileptiform discharges, the epileptic biomarker. But we decided also to move a little bit further. And so we tested if really the 1000 hertz, I said 1000 hertz does not affect the neuron. And what we saw is that the 1000 hertz seems to affect a little bit. But when you increase and you go to 2000 hertz, it seems to affect a little bit less. And when you increase like that up until 9 kilohertz, you have less and less effect. So that's like a new insight that we are bringing, and we could explore it due to the patient that are implanted with this electrode. So that's what I presented during the conference, and I hope we can publish our data soon.
Yes, absolutely. Very, very encouraging results. And what do you think is the reason that this high frequency stimulation has less effect on the brain, and the higher the frequency is, the less effect it produces?
Yes, there is a relation between the higher frequency you get, the more you need to current to achieve the same effect. And we did not vary the amplitude of the current. So you can ask, why does the 9 kilohertz is doing anything? And the answer is yes, because when we are switching to TI at 9 kilohertz, it has the same effect as the TI at 1 kilohertz. I mean, that's an encouraging point to go on with TI with higher frequencies than 1 kilohertz, than what we started to use.
Yes. My next question is, where this field of temporal interference going? What are the next steps that you foresee in front of you?
So I think something that would encourage a lot of team, because so it's a new technique. We never saw the suprathreshold activation with TI. And that's why a lot of teams, I think, of researchers are still not convinced yet. And I think that's a point that a lot of people in the TI field need to work on to make sure that we're for epilepsy, for the patient, if it is subthreshold, but if it's working, for me, it's totally a win. However, for researchers in the cognitive neuroscience, they maybe would like to have a tool. They want to have TI as a tool who can non-invasively target and disrupt any cognitive function, and they can really explore. So I think that's what people are looking for right now.
Yeah, thank you. And in terms of technology, what changes in the technology do you need in order to produce this temporal interference? Is this modification of settings only? You are using the same device, or you need to modify the device? So from that perspective, I'm just curious how many people can already try this approach with their existing technology, or they need to switch to something different.
So, we started to do TI and we had no specific equipment. So we had to do with what was available on the market at that time. So for a new team who wants to start, I'm sure they have some colleagues that have some current stimulator they can maybe borrow if it runs with high frequency. The point would be just to, one, make sure that you can go a high frequency with the stimulator and that the equipment can deliver what they are expecting to deliver. So you have maybe some points to figure it out before doing TI to make sure that the equipment is working the way you're thinking. So you don't need it. However, right now, there are new tools that are developing and are answering questions and issues that we have regarding, for example, the phase of the TI that were needed to pursue and to continue the research. So there are a lot of effort. I know that there are some teams that are working on developing new devices for that, but we do it with what is available on the market right now.
Thank you. And like you already mentioned a little bit, in any new developing technique, there are always some challenges. So what would be the biggest challenge right now with the temporal interference? What challenges still need to be addressed?
So mainly the suprathreshold activation. That's really one of the big challenges. And maybe one of the challenges also right now is to communicate on the TI, to apply it on other diseases. I'm saying that because I am really pushing to, develop new things for patients to help them. I'm focusing on epilepsy, but there is also depression. I know that there is a team in China that is doing temporal interference for depression, but you have also OCD that can be treated. And maybe we can test new things with TI. I think the challenge right now is to communicate a lot for people, researchers, and medical doctors to be interested in the technique and to try it. So that's the challenge. And also a challenge for the equipment to link with the previous question is also to find the sweet spot between having enough current to have a suprathreshold activation and no pain, no sensation. Yeah. So that's a lot of investigation the in terms of parameters. And another one that is coming up to my mind right now is also more preclinical work, more basic research on that. Doing it on the mice is interesting and can really help to investigate what is going on. However, the size of the brain is smaller, so you can achieve more suprathreshold more activation compared to what you can have in human. So what about NHP? I know that there are 2 teams right now that are doing, or maybe 3 teams that are doing NHP and TI. We need more. We need more animal investigation on TI to understand really how it's working.
Yes, this absolutely makes sense. And during the neuromodulation conference, I noticed there were a lot of studies on memory improvement. Then patients with dementia and in general, how we can modulate memory processes. And with the TI really being able to affect hippocampus, this seems as a relevant technique for this type of research and future clinical work as well. What do you think about its potential applications for people with dementia, people with memory loss?
People with dementia, Alzheimer's disease are really hot topic right now. And for a lot of countries, I know in USA, but I know also in France. And that's something that is great with TI. We can test it. I think it's great that we can have something non-invasive and something we can test. I cannot give you the answer if it's working or not. Maybe if it did not work or not enough, maybe we can change the parameter. Maybe we can try to have another placement of electrode. But what is great is that we can try it and we can see if it's working. And even if there is a mild improvement, I think the patient will be very satisfied with mild improvement and compared to nothing. So I think it's great that people are trying that. And yeah.
Yeah. How do you see this field of neuromodulation with TI, let's say 10, 20 years from now? Or how would you like to see it ideally?
Ideally, I would like to see a cap that we can put and we can manipulate it with a computer in distance and it works for everything. And we have our suprathreshold activation. We can move in real time the focus of stimulation. That's how I would like to see it. And I would like to see it more in the therapeutic area. That's ideally what I would like to see, an improvement in the technology, something we can have like a pipeline that we can transfer to a lot of hospital that or research team, something that can be easy to manipulate, and so the research can like evolve and we can try new things. So that's what I would like to see. That would be cool.
Yes, thank you. And what is your next step? What do you want to do yourself in this picture of bringing TI to clinics and, of course, to learning more about our brain?
Right now, I got a postdoctoral fellowship with American Epilepsy Society on trying to, so in epilepsy, as I said, patient can benefit from insertion of electrode in different parts of the brain, and so having the neuromodulation. But the issue is that this target, so you have the thalamus, you have several targets within the thalamus. You have the hippocampus, for example, and also sometimes the cerebellum. There are some studies about cerebellum stimulation. But the thing is, we don't know what will work for which patient. And the study that I will do, I'm going to start in September, will be to try with TI to define that the best target for each patient with epilepsy. So if we have most of the patients, when they come to the epilepsy unit, have to get electrode implanted in the brain so we can have access to the recording of the brain. And the idea will be when you stimulate, for example, the hippocampus, we can quantify the epileptic biomarker, we can quantify the functional connectivity of the brain. And let's say I'm stimulating the hippocampus in one patient. And a few days after, I come back and I'm going to stimulate the thalamus. And the question will be, does the hippocampus or the thalamus stimulation was better? And then, I'm not going to tell the neurosurgeon that we continue that pipeline, but then I can compare the results that I have, my prediction, with what if they got neuromodulation technique. Did the TI could predict or not? So that's the question. Having a tool for epilepsy to predict and if the patient will benefit from the neuromodulation at this place or this place, that's the idea. And then we can move on and think about vagal stimulation. There are also some nerve stimulation technique for epilepsy. So maybe also we can do this on the neck. A little bit. And yeah. But my work right now will be to focus on that. If I can predict which target will work better for which patient.
So, and you are continuing at Emory, yes, here in Georgia.
Yes.
Mm-hmm. Yes.
Yeah.
So we're neighbors in a way. So I'm in Florida, you're in Georgia.
Yes.
We can visit each other.
Yeah.
So, okay, very good.
But I want to go back to France at some point. I need to go. I need to go back. Have baguette and croissant. That's yeah. I'm starting to miss that.
To miss that. Yes, yes, I absolutely understand. Maybe we can talk a little bit about your careers. It's a Neurocareers podcast and specifically targeted for women series. How did you find, first of all, the topic of your PhD thesis? It was very innovative. Yes, you just found something that is just starting, that has so much potential. How did you do that? What would be your recommendations for those who are just starting and trying to find their topic? And of course, they want it to be successful. So, if you can talk about that.
Yeah. So I'm gonna say it was a really big bet because it was trying to find a subject. Because in France, it's not the same. You have the PhD advisor, and then you determine together the subject of your thesis. And I had to find something that was in link between neurosurgery and electrical engineering. And I was graduating in neuroscience. So we had to find something that every side could learn but could at the same time bring into. So I started to work on patients with epilepsy, but with deaf electrode stimulation, like regular deaf stimulation, neuromodulation. But then I really wanted also to keep something more preclinical. So I had a mouse. This mouse, I started to develop this mouse model of epilepsy. And I had this model of it ready. But it was only during my PhD that my PhD advisor came and he was like, look at that paper. Super interesting paper. And he was like, can you try it? And we said, me and my colleague from the PhD program were like, yes. So, and then, here we are. So I think the advice that I would give would be to always be open to new things. And if you can try it, just try it. If it works, that's great. If it doesn't work, you can still continue your journey on your main topic. So the title of my PhD thesis was New Paradigm of Stimulation in Epilepsy. There is no mention of TI because it was not at the beginning. It was totally not the subject of it. Then it was, of course, a big part of my little thesis, but yeah. So the advice would be just be open. And if you are doing what you like, you're going to be very happy to try new things. You're going to be open to new tests. So it's very important to like it. And like that, you can have all the opportunities that will come.
Thank you. And you also mentioned baguettes. Yes, that you really are missing being in France. Can you talk a little bit about your transition? Why did you decide to make this move from France to the States? And maybe what was the most challenging part of that for you?
So I can answer right now. The most challenging was the food. Yeah. No. So in France, when you do your PhD, and when you're done, there is this unspoken rule of you have to go away. You have to go in another country because that means that you can shine on the international scene. You're not only good in France, but you are good in an international scene. So it's easy to, it's easier to go in another country of Europe. It's very small, so we can, but I had the chance to collaborate with a lot of countries during my PhD, and I collaborated with Emory University. So during my PhD, I came here twice, and we started to do some experiment together. I was getting along with the PI that are my PI right now. So I think it was important to have a first look at it. And I knew that when I was leaving to go here, to go in USA, it was not everything was unknown. At least I knew my PI, I knew the lab, I knew some collaborators. So I had to do it for my career because I wanted to, I wanted to show that I'm not only I'm a good scientist in France, but I can be a good scientist also in America. And when I will come back, my career will be better. So that's why I did that. And also the opportunity to, to perfection my English was not worst before. It's great. And now I can talk to you. I can try to communicate. So no, it's a very good opportunity, both for the career and also personally to move abroad. So I recommend.
Yes. So for those who are thinking about it, to go or not to go from the career perspective, what would be your advice?
My advice would be to really make sure that the lab that you're joining or the business that you're joining is something that you really like, because when you're going to arrive, you're going to spend a lot of time with them. It's very disturbing to go live in another country, especially when you don't speak the language. I was thinking a little bit of English, but it's not the same of talking during conferences in France compared to have like a full discussion with someone random in the supermarket. It's completely different. So I would recommend to really be sure that the lab environment and the lab member that you're joining are interesting in the subject you're liking, because you're going to spend a lot of time exchanges with those people. You can be homesick. I was homesick. So, but I was very glad to be surrounded by nice people in my lab, and it was better. Yeah, it got better at some point. The worst are the first 6 months. The worst. Yeah.
Yes. I've heard this rule, if you can live through first 4, 6 months, that's the toughest part. So just make it through and then it will get better.
Yeah.
So
Yeah, and my dad told me that if you're more than 3 years, you stay more than 3 years, you stay forever. So.
Okay, that's a new. Yeah, good to know. Good to know. How long have you stayed already?
2. 2 years.
Okay.
So within a year, I will tell you what.
Yeah, we will see. Yes. Yeah, very good, very good. So, what were the main differences that you noticed between France and the States in terms of the approach to science, maybe grant submissions, anything that you saw was different between there and here?
Yeah, there are a lot. In France, here you to pay your salary, you have to submit grant in research. And in France, when you have a permanent position, you have a permanent position no matter what. If you have grant or not, your salary is going to be the same and you're going to be paid, and no problem. So I think that, but you still need some money to buy equipment to do science. But I think it's a huge stress relief in France. And you can really focus here. If you have all the equipment that you need, you can really focus on only doing your science. Compared to here, you have to think this project is going to be for 5 years, and then in 5 years, and you have to submit a grant. But so it's a little bit more complicated here in USA. The hours of working are different. So a lot of Americans were like, "Oh yeah, in USA, we are working a lot. It must be difficult," but it's not really true. The difference is that in France, you have to be there from 9 to 5 or 6 every day. There is very few flexibility in terms of your everyday work. You're on your every work day, so you don't have like time flexibility. Here, it's much more flexible. If you want to come on weekend, you can come on weekends. In France, no, you have your 9 to 5, you're coming 9 to 5. You can stay a little bit longer, but the work-life balance, I think, is maybe better in France, because when it's 5, it's done. You're out. And in France, what we call apéro, which is a time after work. It's an after work moment when you can spend with your coworker, with beer, with some snacks, and you can discuss about work. But it's I think it binds more, because I think it's a very interesting, like, being with your work colleague around the beer. You can discuss about topic, but it's way more relaxed. And I don't see that here. So it's in terms of work-life balance, I think I prefer France, but I really like the flexibility allowed here in America. And in terms of equipment, we have also very good equipment. And but the thing is that we share only within the university, and with some other university. Here it's really Antwerp University, I would say. But yeah, that's the main difference that I'm thinking of.
Thank you. And you are actively pursuing your career. Yes, you didn't stop after you finished your bachelor's. You went and you did your PhD. You're doing your postdoctoral. What is the reason for you to doing all this? Why the career is important for you? so that you were not stopping and pursuing it very actively?
Because I had the opportunity to go on and go on. It's true that I never took a moment. It's just that I had, we say in French, you have to beat the iron while it's still hot. So I think that right now, if I'm taking a break, there is an exponential curve for GI. And so if I'm out for a year, I will feel like I'm behind, which might not be true, to be honest. Maybe it's only in my mind. My parents were hardworking people, so I think they gave me this way of life, of thinking. Of course, my career does not define me, but that's something that I want to, work on it. I like what I'm doing. So that's why I never thought about taking a break. Maybe later. But yeah, I think when you're doing something you like, you don't see the time go passing. So maybe that's it.
Yes, yes. And you mentioned that doing something you like. One of the questions was, what really motivates you to continue, yes, to do all that? And I'm sure there are many challenges, yes, even moving from one country to another country, adopting to all the new things, new changes, yes, pursuing this new field, although it's unexplored. Some people may still not really believe, yes, that it does something like you mentioned. So what keeps you going? What is that internal motivator for you?
So I hope it's not cliche, but I'm going to say the patients. When we did our first epileptic patient, it was something really like not tested at all. Yes, we had there were some papers saying it was safe. We knew it was safe. We worked on the ethics for a while. Everything was great. But, you know, I was very concerned of, I hope going to hurt the patient. I hope everything will be fine. And what if, you know, you're thinking in your mind. And I talked to that patient. I was like, are you okay? Are you comfortable? Please tell me if you feel anything. And he was like, yeah, no problem, no problem. Everything went fine, how it was supposed to. And I was talking to the medical doctor and I was like, he's not afraid. I mean, we are here, we have like these giant stimulators and there are like thousands of wires around him. And he was like, he has epilepsy since he's a child. He has 3-5 seizures a day. He is like, he is in need to treat that. And and then I said to the patient, like, is it okay? How you feel? And he was like that, if it can help little children who have epilepsy, I'm fine with it. I would like to avoid other people to go through what I'm doing. And that's, wow. I mean, there is a need. There are patients who need to have new therapy, they can try whatever if you're like, you can ask them to do whatever if it's to try it. And if they have hope to treat that disease, they are going for it. And I never had one patient who said no to the trial to go to get in. So yeah, it's the need of the patient. And especially that discussion was really a motivation for me.
Thank you for sharing that. What would you say was the biggest challenge on all your career journey so far, and how did you solve it?
I think the main challenge is you have being a researcher is being like a medical writer, is being an experimentator. You have to create your protocol. You have to order mice. You have to deal with security and the lab. It's the biggest challenge is to have time to do everything and everything correctly. So that's the biggest challenge, I think, in my career. I'm only a postdoc, but already writing grants. I'm already mentoring some students, and it's a lot. And then you don't see the time going, but you still need to do publication, and don't forget to, you have a surgery, you need to supervise him and that, and it's the biggest challenge is to be done with everything and being done correctly with everything. That's the biggest challenge. And I would argue for more using the best skills of each researcher to have like a real team. I think and that's also something different from France and here in USA. I feel like here, labs, just one PI, maybe one researcher, one scientist, two or three postdoc, and PhD student and undergrads. And I think that the stress and the work that the PI has to give to maintain everything is much more than being a part of a bigger group. And like that, all the skills of each researcher can be put to have like a common work, like a common force.
Yes, thank you. One thing I wanted to ask you about TI is that, it's a new field. Yes, you are one of the first explorers. Yes, when you are especially exploring something new, you find something that you didn't expect even to find. This makes the journey even more exciting, I think. So, what were those unexpected things that you found out from your experiments, from your research that really surprised you?
So I was not thinking that the sham worked. The carrier by itself, it was a surprise, but not really a surprise. Yeah, I was confident that, okay, maybe 1K was a little bit low, but 2 kilohertz, I was not thinking it's going to work. So that was a surprise. I think the unexpected results are more something that you think they're working in a certain way, but then when you try it, you're like, no, it's totally fair. It's completing the story. So the sham was something that I was not expecting. And also on the mice, I had one that I don't have the answer still, but I tried to repeat the Grossman results, with the anti-gyrus activation. And I had it every time. So I'm like, that when an experiment is working every time, that's weird. So that's another expecting result that I'm trying to solve. Maybe it's my fault, probably my fault, but we'll see in few more. Yeah.
Thank you. And now maybe you can give some advice to those, especially women, yes, as it's a podcast for women who are trying to pursue their careers in the field of neurotechnologies, maybe neuromodulation. What would be your advice, your suggestions for them?
I think it's not even just in neuromodulation. I think it's for science in general. Speak out and stand out. Be the center of attention in the correct way, for your science. Just don't be afraid to say what you think and to disagree. Sometimes men, I don't want to generalize, but I know a lot of men who are, what they are thinking should be more like they don't start their talk with, I think that. No, it is, even though they are wrong. And I feel like as a woman, and I see other women doing that, it's just started like by minimizing their thoughts. Like, I think, I am not sure, but no, just say what you're thinking and it's probably correct. And don't be afraid that when you hear something that doesn't seem really too perfectly right, don't be afraid to point that and be like, don't think he knows more than you. It's not true. So we need to be more confident as a woman. And I'm saying that also to myself. I'm trying to, the same thing that I just said. I'm trying to say it in my head when we are in lab meetings or in conference. Just go for it. Yeah. you deserve to be here as much as they deserve to be here.
Thank you so much. That's great advice because indeed we tend to have a lot of self-doubt, the self-talk, talking ourselves out of something, doubting and even belittling our opinions, our ideas. So that's great advice. So thank you very much for that. And what do you think about your future career? Are you planning to pursue an academic career going forward after your postdoc, or you are planning more to go into the industry, creating some devices for, again, clinical applications? Because there is a tendency right now for people to go into industry. So what are your thoughts? At least at this moment, it might change, of course. Yes.
Yeah. And I'm going to be very honest. I'm going to say, I don't know. Really, I like to see where the wind is pushing me in which direction. I know that I want to go back to France. That's one thing. I like both. So I would like to be pursuing the academic career because I think you have more freedom. You have more, there is like a possibility to express yourself in a way that is not possible in industry. You can really work on what you want to work and pushing in the direction that you want. Although in industry, you can be the impact that you're going to have as a team because it's like a business. I'm thinking about the big businesses in neuromodulation. Their impact is much bigger. And if you want, and they are the last, not really the last, but they are really closer to the patient than you are. So even if like TI can be a good tool for epilepsy, I cannot go in the street and sell TI device. No, it's not going to work. We have like to have like a very good business to put like a force of action toward having device and TI implanted in clinical setting. So that's a fair question that I don't have the answer now. Do I want to be a part of a group that will help patients by giving the device, helping the hospital and the clinician to put it in place? Or do I want to be on the other side of exploring and trying to find how it's working the best? But it's I'm not. I will see when opportunity.
Yes, and you will see the opportunities, like you say, you're also, in a way, trying to feel what's coming, and you are taking on the opportunities from what I've noticed.
The only thing that I'm sure is that I want to continue to help people, and I still want to be an actor of that, even if TI is not working the way that we are thinking it is, or if it's finally not the good solution for this patient, but it's fine. I just want to continue, and yeah, that's the only thing that I know.
Yes, yes, and of course, this can be done in various ways.
Yeah.
Yeah. Absolutely, absolutely. Yes, so it was a very engaging conversation, many important insights that you shared with our listeners and great advice. Maybe there is something that I didn't ask you and you would like to share with our listeners?
The only thing that I want to share, since it is for women in neurotechnology, is just to try to convince people to come. It's fun. We need sisterhood, be together and support each other. So that's the main message that I would like to say. To say again, it's just we are not alone, and we can do great things together. And we deserve our place. We deserve everything that we have. We own it. And I hope, and never forget that you can be maybe the highlight, the motivation for other little girls, PhD student, undergrad. So don't break their dream. Just help them to go forward, and maybe we will be more women than men in in neurotech soon. That would be cool. Yeah.
Yes, thank you so much. And yes, like you said, that we can be those inspirations, like Dr. Trebuchon.
Yeah.
Trebuchon was for you.
Yeah.
Yes, so we can inspire
Yeah.
younger girls and yes, women. Okay, so thank you so much, Emma. It was a true pleasure. I wish you all possible success in all your endeavors and helping patients and developing different ways to help. And I hope to see you in a couple of years again in our podcast with updates on what's going in the field and what are your contributions and career development. So thank you so much.
Thank you very much. That was a pleasure. Thank you.
Dear Neurocareers podcast listeners, thank you for joining me and my incredible guests on this exciting journey into careers in neuroscience and neurotechnologies. I hope you've been inspired by the stories of those turning groundbreaking ideas into impactful realities. If you are looking for more guidance on advancing your neurocareer, book a free consultation with me, Dr. K, your podcast host and neurocareers coach at the Institute of Neuroapproaches, the only career service dedicated specifically to the needs of professionals in neurotech. Let's take the next step toward your neurocareer success together. In addition to free consultations, the Institute of Neuroapproaches offers a variety of services designed to help you thrive in neurotech. First, professional development planning. We help you create a tailored career development plan, identify knowledge gaps, and equip you with the tools needed to achieve your goals in neuroscience and neurotechnologies. Second, resume and cover letter review. Get expert feedback on how to craft documents that are specifically designed for job opportunities in the neurotech field. Third, interview preparation. Sharpen your interview skills through mock interviews and targeted feedback, including soft skills, hard skills in neurotech, BCIs, EG, MEG, live coding, and presentation preparation. Four, networking and job search strategy. Learn how to effectively network and uncover job opportunities while standing out in the competitive neurotech job market. Five, negotiation and salary advice. Receive expert guidance on negotiating salaries and benefits and determining a fair salary range for your desired position. All this and more can be found at www.neuroapproaches.org. Again, www.neuroapproaches.org. So, what are you waiting for? Let's navigate the path to success in the world of neurocareers together and turn the impossible into possible. We're looking forward to working with you.